Alright, so when you're ready for your FEA testing, what we can do is, obviously in the last video, you've got your front wing, alright, that you've split from the rest of the body. Alright, so what we're going to do is create a study in a second that's going to show us how strong these wings are. Alright, and then you'll be able to test to work out if there's any stress points and things that you can do to obviously to improve the strength of the wings. Alright, because when you get to the end of the track, you obviously want the wings to withstand a fair bit of force so they don't go snapping during racing. Alright, so what we can do is go over to design, and we're going to go to the simulation setting here. Okay, now when that loads up, you've got a static stress that we're going to conduct. So click on that one. I'm just going to move this one up so I can click on create study. Awesome. Now your car should appear. Now the reason why some of mine are missing is because before I went into model components, and you can see some of them are removed. So what I want to do is just continue to remove all the components that I don't want in this test. So we're basically just going to keep just the front wing if we can. Alright, so I've got rid of everything else. If I open up bodies, there's two different bodies. So I'm going to remove body 4 just so I can keep the front wing. Okay. Alright, so once you got that sorted, we can close these down. Awesome. Now, what we need to do is set a material to this part. Okay, and the way to do that is to go here, and we can go study materials. Alright, now I'm just going to move it to the side. Now when I click on this one, here we are. So this one, if I extend it out, is body 1. So that just lit up for me. Alright, so for body 1, I'm going to change the material here. Alright, and obviously, everyone's going to have different materials for their 3D print. If you use PLA, which is a pretty common 3D print filament that you use at school, that's not currently in the system here, so you would have to make a new material, which I can show you in another video. But if you're using a material like, let's just use nylon 12 for example. Oops, just click N, sorry, and then I'll come up with all the ones that start with N. Here we are, nylon 12. Alright, so let's say for example that's our material that we're using. Okay, we can then press OK. Now, it may come up. I can see there's a red icon here to say that it's not ready for testing. Alright, at the moment, because we haven't set a material for the rest of these parts, it may cause an issue. So we may have to come back to this later and fix it. Alright, but because that's the only thing visible, alright, we'll just leave it at just nylon 12 for body 1 for now. So we'll just press OK, and hopefully we can get through that. Awesome. Alright, so the colors changed, so that's all set to nylon 12. We need to now set the mesh. So if we right click on this, and we're going to generate a mesh. Now a mesh is it's basically it's a 3D mesh, which is the structural build of a 3D model consisting of all these polygons. It's basically reference points in the X, Y, and Z axes. And it defines like the shapes with like height, width, and depth. So if you could imagine like a fishing net over the top of your 3D model, it basically molds around that shape, and you'll see that in a second when I generate. Alright, so I'll just generate as it is for now, and this may take a little bit of time. Alright, I'll pause the video, and when that's done, I'll let you know how much time that took. Alright, so that was about, 30 to 40 seconds, so it was pretty quick. But as you can see, you've got all these shapes, these little polygons and triangles that are sort of shaping up on the surfaces. Now, obviously, if you want more accurate results, alright, you want more of those shapes on there. So you can change that when you do the mesh settings. Alright, and if you just decrease the size of this, if we went down to, it's not giving me a value, but I'm guessing it's about, 6 or so %. And then we go right click and then generate the mesh again. You should notice a difference. So I'll just pause the video again. Alright, so that was about 30 to 40 seconds again. But yeah, as you can see, there's more shapes formed on here. So the meshing is more accurate now. Alright, so the finer the meshing, alright, the more accurate your result will be, because it'll grab more point on your 3D model that it can then test in the simulation. Awesome. Alright, now we need to add some constraints to this as well. So we basically want to show what point of this is going to be fixed, just so it knows that that's the part that isn't going to move, and everything else is going to move sort of around that point. So for us, it's going to be this side here, because that's the part that's going to be obviously glued onto the car body. All right, so if we go to constraints, all right, and if we click on that surface there, see it's got a padlock on it, so that's going to be fixed. Okay, so that surface there should hold itself. Okay, once that's done, press OK. All right, you'll see the padlock that will stay. All right, and then we need to add some loads to this. So we'll click on loads. All right, and then you can select where the force is going to be coming from. Now, obviously with your car, it's traveling in a straight line and it's hitting into some towels or some brushes or whatever it might be. All right, so what you're going to do is just click on that surface. Okay, you can change the angle of where it's getting hit from. You can do all sorts of stuff to it, but for us, we'll just keep it simple. We'll have one there and one over here as well. Okay, so it's hitting in that direction. All right, straight into your wing. All right, so we'll just leave it like that for now. Like I said, you guys can change it if you feel like your wing's going to be hit from a different direction. Awesome. All right, so that's that. So you can choose the force in newtons. Now, the figure that I'm about to put in is based on 2 kilos of force. Now, the reason why I'm doing that is because for the World Finals this year in 2023, they did a test in scrutineering for the halo that they introduced, and they had to put 2 kilos worth of weight onto the halo, because that would represent basically the elastic band that would hit into the halo to slow it down. It will slow the car down at the end of the track. So just using that as an estimate, I've decided that 2 kilos is basically what I'm looking at as the load at the end. So I basically just went onto Google, did a conversion, which was 19.61 newtons. So I'll type in 19.61, and that should give us a rough sort of estimate of what we want to be looking into. And that's probably worst case scenario as well. So if we press OK. Okay, so we've put this constraint on. We've shown the direction of the force of where that's going to be applied from. And all that's left to do now is to go through and to solve the test. So I think if we right click here, we can go to solve. Now I can see with the pre-check there's still a red little icon, and I feel like that's the materials, but we'll go solve anyway and we'll just see how that goes. Alright, so you see here it's not letting us do the test yet. Click here to select materials. Alright, so obviously it's some materials haven't been added yet, so we'll do that now. Alright, so once again, like, realistically, because we're not really testing the other parts, we can just set it to whatever material we want. But if you wanted to make sure everything was like as accurate as you could, then you can make sure that these were the set materials. So, for me, once again, I'm just going to go through and do just nylon 12 for all of them. Okay, I'm just going to pause the video after this one so I can go ahead and finish all those off. Alright, so I've gone through and I've listed them all as not nylon 12 for now. Just press OK. Awesome. Alright, so now it's changed to yellow. So I think this will allow us to go through and test it. So we'll go solve. So all the stuff that we hid before is still going to be included in the simulation. Okay, so it doesn't really matter. We'll just press continue and then go solve. Alright, so that's scheduled it It's starting to run. Okay, now I'll pause the video and then come back once that is completed. Okay, so that took about, I don't know, 4 or 5 minutes. Now it comes up here and it says the actual minimum safety factor, and it says 15. So when we close this, and we'll close this here, okay, it's showing that at the moment we're ranked in the safety section. Okay, so it's recommended that you're above 3. Okay, so if you're in this area here, then obviously the material's gonna withstand the force. But you can tell there's quite a bit of displacement, and that's obviously worst case scenario if you put that much weight on those wings. So if we change this to stress, all right, and what's really good about this is it can show you where the stress points are. Okay, and if you drag this arrow up, you can then really focus on some of the worst points, which is probably in this range here. Okay, so one thing I noticed straight away is definitely around sort of the join here, all right, is where obviously there's the most amount of stress. Now, one way that I would easily overcome this problem is putting a fillet on there. So if I was you, yeah, I would have a screenshot of this to show, okay, well, this is what we've got first of all, okay, and then have another screenshot where you put a fillet on there, and that will show a massive difference in obviously the stress points. So it should be able to obviously withstand a lot more force if you've got fillets across here, okay? Because the point of breakage isn't obviously in that little crease line, it's obviously spread out along that whole entire fillet, so it can yeah, withstand it. All right, I'll just drag that back down. Okay, so you can quite clearly see where all those sort of stress points are. And like I said, it's worst case scenario. It's not going to deform this much. The other thing as well we can do is displacement. All right, and it shows you obviously the parts that have been displaced the most. So you can tell obviously this was the original spot. This is where it is now, and you want to try and keep or reduce it down to at least or less than 4% displacement. So if you can do that, then obviously your part's not too bad. But you do want to at least show that you've analysed this and you want to obviously make improvements. So if there's certain parts that show you that's displaced like way too much and there's causing heaps of stress in certain points, if you can try and improve those bits, then obviously that's going to it's going to be beneficial for your car, but also for your judging as well. All right, now something else that you might find interesting is you can do animations. So if you want to show judges, how things were displaced and that sort of stuff, you can go up here to animate. Okay, now if I press play, it shows you obviously that force being applied. Now, obviously you can change the steps. So rather than it being all clunky sort of like that, you can bump it up. Let's say we do 50 steps. Press play. All right, so now it's obviously a lot slower, and you can see it sort of all happening. You can change the speed, so it's a bit faster as well. You can do it two ways, so it shows you going in, being bent backwards and coming back to its original shape. All right, so there's stuff like that you can do as well. Okay, you can record it. So obviously, if you wanted to keep that capture to use as evidence for whatever reason, that's obviously fine as well. Okay, so yeah, that gives you a basic overview of what this feature does. So I'm sure you guys will find that handy for your F1 cars. Thank you.